In this video, I'm going to talk to you about comparing the graphs of standard form for quadratic equations and then also for factored form. And so in this video, I'm actually going to show on Desmos. So it says observe the graph in standard form function on Desmos graphing calculator. And so I'll show you what that looks like. And what we're going to do is find the intercepts and the vertex. And then what we're going to do is rewrite our equation in what is called factored form. And then we're going to observe the factored form of the function on Desmos and then find the x-intercepts and a vertex. So if you don't have a graphing calculator, you can go to this website. It's called Desmos, DESMOS, .com. And it will graph for you your function. And so I'm going to show you that in just a minute. But here I want to just kind of tell you what function we're going to do first. It's y equals x squared plus 6x plus 8. And I'm going to go online on Desmos, and what we're going to do is identify the x-intercepts and the vertex. Then what we're going to do is factor this function and then observe the same function in Desmos side by side. Okay, so here I'm just going to kind of bring you to my computer screen. I'm going to do my best to show you this with one hand. Okay, so we're going to hit graphing calculator here. Notice I'm on just desmos.com, and I'm going to type my function in here. So give me just a second. This is going to be, hang in there, y equals x squared. So I'm just going to type this in. I'm going to use the bar here to hit my square, plus 6x, and then plus 8. So here's my function, and I'll pick this up here. So here's my function, x squared plus 6x plus 8. And what I want you to see is the vertex here. You can click on this point and it will show you what that point is, as well as your intercepts. And that's what we want to observe here. So now as I go back to my piece of paper here, I'm going to be asked, identify the x-intercepts and the vertex. What I'm going to do is write that down here. So notice -4, 0 and -2, 0. And in between them at -3, -1 is going to be our vertex. So let me pop back up here and just kind of focus for a second. So our vertex was at -3, -1, and our two x-intercepts were at -4, 0, and -2, 0. And now what we're going to do is factor this function. So what two numbers multiply to make +8 and add to make 6? Those two numbers, I hope you're thinking of them right now, would be a +4 and a +2. So now what I'm going to do is type that function in on Desmos. So here we go on my computer. I'm going to click for where it says number 2. I'm going to try to focus you as best I can. I'm going to say y equals, and I'm going to put in parentheses x plus 4 and my parentheses, and parentheses x plus 2. And so there's my function, and it is in the color blue. So notice if I change the color to red, or turn it on and off, I should say. So this is turning it on. This is turning it off. Notice it's the exact same picture as the original picture that we had in standard form. And so just kind of as observance, you'll notice that factored form and standard form produce what is called the same picture. And so on my sheet here now, back to our notes paper, it says observe factored form function in the Desmos application, which is what we did. Do both forms have the same x-intercepts? The answer is yes. How about the same vertex? Again, yes, they are the same picture, because if you were to multiply this out, you'd have y equals x squared plus 2x plus 4x plus 8. And isn't that the same thing as what you had up top? Yes, it is. So that should kind of make sense that you would have the same picture. Okay, now I'm going to do the same thing again, but I'm going to switch my two functions to this new function. In standard form, now x squared minus 14x plus 48. We're going to identify our vertex and our x-intercepts. So I'm going to get my vertex ready, x-intercepts ready, and now our factored form. So before I type it on the computer, I'd just like to get both forms ready to go to type out. What two numbers multiply to make 48 that's positive, but will add to make -14? As you're thinking, I'm going to get my factors ready. X times x will get us x squared, but the two numbers that will multiply to make 48 and add to make negative 14 are negative 6 and negative 8. And so now I'm going to go over to my computer and type in both of these functions. So x squared plus, for this one we had negative 14x and then plus 48, so I'll just put a 4 in front of that. And then for our factored form, actually I want to turn this one off. Okay, so here's our new function. I have an intercept at 8, so if I hover over that point, I can click it and it will show up, as well as the vertex. So let's write down our intercepts are 6 and 8, and our vertex is 7, negative 1. So here we go. Vertex was 7, negative 1, and we had an x-intercept at 6, 0, and 8, 0. And now I'll type in our factors on the computer. We had minus 6 and minus 8. Okay, so here we go. There's my picture. Minus 6 and minus 8. And when I click this blue button, it should hover right over that red graph. So notice how the red graph and the blue graph are exactly the same. So they should have what is called the same, they should be the same function, because if I were to actually multiply this out, I'd have y equals x times x, or x squared, x times negative 8, or negative 8x, negative 6 times x, or negative 6x, and a negative 6 times a negative 8 makes a positive 48. These two middle terms do combine to make your negative 14. So our observations are that we had the same graph again. And our x-intercepts were at 6 and 8, and the vertex was at 7, negative 1 for both. So do both have the same intercepts and vertex? Yes, they did. Okay, so we have one last one here to just kind of explore. Now this one you'll notice is a quadratic equation, but it doesn't have all three terms. It actually only has two terms. And so let's find our vertex and let's find our x-intercepts. And I'm gonna, before I use my camera, I'm actually type that one out first. So 2x squared and plus 8x. I am not so good at typing and showing you guys on the computer, so give me just a second. Here we go. So here is this picture. Again, I'm going to pop you over to my computer screen. Here's 2x plus 8x, so I type that in. Here's our picture on Desmos, and if I can just zoom in a hair for you. Here we go. I'm going to click and hover over this, what looks like our x-intercept, and it is 0, 0, and another x-intercept at negative 4. And the vertex, the lowest point on our graph, is negative 2, comma, negative 8. So I'm going to write those down. So negative 4 and 0 were our x-intercepts, and in between there, right in between negative 4 and 0, because it's symmetric, negative 2, negative 8 is our vertex. And so here, let's focus. Vertex was at negative 2, negative 8, and then our x-intercept was at negative 4 and 0. So if you want to write it as a point, you can. Or if you want to just say negative 4 and 0, that's fine. And now factored form. Both of these two terms are divisible by a greatest common factor, which would be a 2 and an x. And if I divide by 2 and an x, I'll have 1x, and I'll have 8 divided by 2, which will be a 4. So notice if I were to set my factors equal to 0, 0 divided by 2 would get me 0, and I would get here negative 4, which is why these show up. And just because I wanted to compare for you, I'm going to type this out on Desmos real quick here. So 2x, and then in parentheses, x plus 4. Notice how, okay, here's my computer. I have 2x and then x plus 4. So notice how this graph is now green. So notice it's the same exact picture as what we had before. It didn't change at all. In fact, I have them both graphed at the same time, and if I click my green graph off, I get the red graph that I had originally. And notice how that is exactly the same line. Okay, so factored form or standard form, no matter the form of your quadratic, you will have exactly the same graph. I just want to narrow in on, well, why the heck are there two forms? Well, there's two forms because sometimes you factor and sometimes you don't. And why would you factor versus not factoring? Well, standard form of your function, if you have your quadratic in what is called standard form, so again, I'll just kind of remind you, this is ax squared plus bx plus c. This form is generally used for strictly finding axis of symmetry, the vertex, the max or the min, and the y-intercept, because your parts of your graph are how you find those things. And actually very easily. So axis of symmetry is that formula x is equal to opposite b over 2a. And then for your vertex, you find your x that way and then you plug it in to find y. So we called this opposite b over 2a. And then you evaluate your function at opposite b over 2a. That's your vertex. Your min and max will be determined by your y value of your vertex so that you can find. And your y-intercept is always the c value of your graph. And so that number you can easily pinpoint because it's just right there in your equation. But factored form is generally used for specifically just finding your x-intercepts. Now your x-intercepts are also referred to by other names called roots or zeros, or actually solutions. So if you factor, now I'm going to write down what our book calls the factored form. Now these m and n would be the numbers that multiply to make your c term and add to make b term when your a is 1. And you may or may not have 1x, so if you had a number in front of your x squared, obviously your factors will change a little bit, like you might have a number in front of your x, but generally speaking, your factors, you set them equal to 0, just like I showed here, and you'll get your x-intercepts very easily. And so the difference is just, well, what are you trying to find? And then utilizing your function and the properties of your function to find what you need. And so now what I'm going to do in my next video, because this video is getting kind of long, is graph two different forms. Now these are different equations. Actually, you're going to see that they're not. They're the same equation. But I want to show you side by side how to graph when you're given standard form and when you're given factored form, and how you will get the same picture. It's just kind of how you go about it. The process is a little different. So stay tuned. Again, we're going to compare standard form and factored form of your graphs.